Chapter 8 is actually several different things, or this unit is several different things. We're actually going to be doing the actual inference tests, and there are two types. There are confidence intervals, and then there are inference tests like hypothesis tests like you do in science, which is actually pretty cool. So we're going to start off with a confidence interval, and that's what we kind of did on Friday. For those of us who were here, and we did that mystery mean, like y'all were trying to estimate what the mean was given the sample. Okay, so that's what a confidence interval is what I told y'all. So this is just kind of like a random what if question. Something that we can think about as far as that we'll be trying to answer throughout the unit. They want everybody to answer the calls within 30 seconds. Are you looking at the Google Meet presentation? Is it not presenting? Okay, I'm like losing my... I was gonna say I don't have long enough to list that answer. There's just too many things. There's too many things. So they want to answer all the calls within 30 seconds. This is a random sample of 241 calls. That's what the histogram looks like. So, does it look like they answered most of their calls within 30 seconds? Yeah. If you were to describe the shape of that graph, what would it be? Which way? Skewed right. So we have a few that are on the higher level that kind of pulled it up there, right? But for the most part, it would be pretty daggone good. And where do you think the mean and the median would be? Just an approximation. That's 241 calls. We know the median would be about 120. So 45, 65, that'd be like 100. Somewhere around here, around 15 seconds is the median. But do y'all remember what happens when we skew the data? What happens to the mean compared to the median? If my median is at about 15 and it's been skewed to the right, is the mean higher or lower?
Isn't it higher?
It's higher. The mean gets pulled towards the tail. Very good. So that means our mean would be somewhere above 15, but not too much. So their mean, their average of their sample technically is less than 30 seconds. So we could say that they were successful. Okay. So that's the kind of things that we are going to be able to answer by doing a confidence interval. For those who were not here on Friday, this is pretty much what we did. We did a mystery mean. This is my sample mean from a sample with a standard deviation of 20, and I took a sample of 16, and I made them give me some reasonable values, right? Some reasonable values for the population mean that I would be actually making an approximate from. If you want a game, I'm gonna take them. I'll smack you up. Come over there. I'm gonna come over there and pop you with that iPad. That's gonna be it. So for those of you who were here Friday, do you remember what we came up with was a reasonable interval?
It was in the 68th percentile. I remember that.
So it was one standard deviation below. So 113.45 to 123. And we figured out that was 68% because that's one standard deviation above and below. And if I wanted to go to 108.45 to 128.45, and that was 95%. And we talked a little bit about how most of your confidence intervals are going to be 95%. That's just because that seems to be the most popular. Willing to be wrong 5% of the time for not having like a ridiculously large interval. One of the big things I was explaining on Friday, again, for those who are not here, the cartoon that's actually in the book is a really good example. Garfield is sitting on the chair and he's watching the weatherman. The weatherman's like, it's going to be somewhere between 20 degrees and 100 degrees tomorrow. And he's like 100% accurate, right? Definitely 100% accurate, but the interval does not help me figure out what I am going to wear tomorrow to go to work. So you have to sacrifice one for the other. You have to be a little bit less exact and be willing to be wrong a little bit so that you actually have an interval that means something. Because telling me it's going to be between 20 and 100 degrees tomorrow means nothing. I'm like, oh, yay, that's pretty much almost every day of the year. No problem. So, all right, so basics behind standard deviation. We did that one. This is literally just, if y'all want to take like a screenshot of this real quick, this is how we actually worked through finding, oh no, that's bad. Let me do that in several pages instead. That was a really small one. I didn't realize how far it had gone down. Okay, y'all got a screenshot of that one? Okay. And we actually did do the standard deviation of the sample by doing 20 divided by the square root of 16. That's how we got 5 going up and down on Friday. So we did actually do the standard deviation. Okay, and then if this is exactly what we talked about. See how bright y'all are? We didn't even actually have the notes for this, and y'all were already thinking in terms of this stuff. Very cool. So an answer to that question at the bottom, in 95% of our simple random samples of size 16, X bar would be within how much of mu? 10, right? 2 standard deviations? 10 on either direction. I'm not mistaken, it's actually there. Yep, within 10. And that was the interval that we talked about, 108.45 to 128.45. Reasonable interval of where our population mean would be. This part is the only new one, and it's the actual formula for confidence intervals. Estimate plus or minus margin of error. Okay, and a margin of error is actually created by 2 pieces: your standard deviation and what's called a critical value. And the critical values and stuff are what we're going to be talking about today. Have you ever seen like a newspaper article or anything that talked about a margin of error? Right, how far above or below you're willing to go on your estimate? Somebody won with 53% of the votes, plus or minus 2%. That's a margin of error. Yeah. Okay, so just so you know, the estimate has to be a sample statistic, period. Otherwise, why is it an estimate? And a margin of error is 2, 1, however many standard deviations, what or what? Above or below. Okay, the estimate always has to come from a sample, period. I think on your formula sheet, doesn't it say statistic plus or minus critical value and then standard deviation, something like that? The one where it's actually, the formulas are actually in words. I thought it actually had said that. When it gave you like your z-score thing in words, didn't it actually have something like that? It does in words? Okay. Didn't think I was going completely loopy. I mean, there's always that possibility, but. So how does it phrase it? Standard error of the statistic. Good. Okay. So excellent. It actually gives it to you in words: statistic plus or minus critical value times the standard error of the statistic, which basically is your standard deviation of your sample. That's all that is. If you see it in symbols, I do want to give it to you in symbols. Okay, so if we do a mean, the mean would be that plus or minus, times the standard deviation of a mean, which is divided by the square root of n, right? That's that one. And if we're doing proportion, it's p hat plus or minus z critical times, oh Lord, what is it? P1 minus P all over n. Right, those are the standard deviation formulas. That's the actual formula in symbols. So in words, that whole big thing after the plus or minus is your margin of error. That little star stands for your critical value, meaning how many standard deviations above and below do you want to go. And there are actually numbers, which we'll look on our Z table today to see. It's actually pretty cool because of the symmetry. Okay. So, questions so far? Again, we are actually making very specific, I'm not going to say a guesstimate because a guesstimate does not sound precise. This is an actual mathematical estimate of a population. Right, what we talked about, like, can't take a census, so take a good sample and then let's figure out what we're going to get. Alrighty, basics. Point estimator. Okay, you actually have what's called a point estimator and a point estimated. Point estimated. I'm done. Point estimator and a point estimate. That was good. All right, full distribution. Do what? Couldn't even get the words out. Okay, so a statistic that's used to estimate a population parameter, right? And then the value of that statistic is the actual point estimate. So we've kind of talked about this before, about how I told you a parameter doesn't have numbers, a parameter is in words, right? Okay, kind of makes sense, right? The point estimator, you've only got really 3 choices of things that we're going to actually be estimating. You're going to do mean, you're going to do proportion, and then later we're going to do slope, which is beta. I don't know if that's written correctly, but I think it's supposed to be like that. A B with kind of like a long tail on it. I don't know, somebody look up the Greek letter for me. That's supposed to be a beta, and it stands for slope. That's like the last thing we'll be doing is estimating slope. Okay, so whatever value it is, whether it's a decimal or a proportion or a slope value, that is going to be your estimate. And what do we really, really hope? Because we want to sample well. Low to no what? What were we trying to get rid of last unit in the sampling distributions? Gun range. There's a word for that. It starts with a V. That's the other one, and the other one is variability. You had it right. It was the spread. It's just the V word. So we don't want it to have bias, and we don't want it to have a whole lot of variability. Right? That's that kind of that trade-off on making our confidence interval smaller. Not as much variability. Anybody else remember how to make the variability even smaller? From the last one? How can we make our standard deviation smaller?
You make the number bigger.
What number? Sample size, very good. We have to increase the sample size. Increase the sample size and any standard deviations above or below. If you make it smaller, then your margin of error gets smaller, right? And if we increase our sample size, then our margin of error gets smaller. What's up? You just being weird? Okay. Oh. As long as it's not that Russian guy doing rapping in that really obnoxiously loud or high voice. No. No, please, Lord, no. All right, so. No, that's not a laugh.
Like in certain animes, like the way they laugh is just based upon like it's so weird. And that's how it is after all the anime. That's how you laugh.
So he sounds like he's on crack. Okay. So let's go ahead and do this.
He pretty much is.
Yeah, this is how outdated this data is. I need to update this. This is from 2007.
Oh, yeah.
I should have been able to get a new one after 2019.
That number is much larger now.
Scroll up. Right here. Okay. Just let me know. Y'all, I've been telling y'all that since January. If I'm going too fast, just tell me. I'll pause. I'll go back.
41 students for answer, not 28. I mean, 2019. That would be much bigger.
Probably.
It'd probably be 12, no, more like 13,000.
Well, here's the thing. Most of them, you wouldn't be asking them if they smoke anymore. It'd be if they vape.
And it's gonna be, yeah, if they smoke, they vape. If they vape, they smoke.
I know people who don't do both.
No, I'm not talking about cigarettes. I'm talking about cigarettes specifically.
They're talking about cigarettes. We're not talking about other things.
Cigarettes, the number will probably be like 8,000.
Okay. By the way, it wasn't 12. It was 2,808 out of 14,000.
No, I'm saying
Oh, okay.
today it would be 12.
Oh. 12,000? I hope not.
So I said people like half.
I hope not.
Yeah, I would say
I would hope people would be getting better. Okay.
it's
So,
like half.
point estimator. Are we looking at a mean or a proportion or a slope? Okay. A mean, remember how we talked about whether or not something is quantitative or qualitative data? If you can take the average of something, are we looking at the average number of kids who smoke? It's not the average number of kids who smoke. It's part out of a whole, which means it is a proportion. This is a proportion, a part out of a whole. Part of a total. Trust me, if it's a mean, it's going to give you a statement. Like with an average of da-da-da-da-da-da. When it doesn't give you that type of information, it's a proportion. It's a part of a whole. Like it's basically giving you two counts, like your total count and however many out of that total. That's a proportion. Okay, what is the actual value of p hat in this case? And I do want the decimal, please. We know it's going to be 2808 out of 14041. Right? We don't do naked answers, so write the fraction first, but I do want the actual value for that, please. Got your calculator today. Score. Doing good. No, I wasn't being mean. I was asking.
Yes, I got my calculator.
This is good. Anybody need to charge their calculator today?
No, I need to charge mine.
Oh, okay. Well, yours is plugged in right now.
I mean, 5%. That's someone got 4.
Yes, Caitlin. Question
If
or
I bring my
volunteering?
calculator to practice, can I plug it in?
Yes, I'll just bring the cord with me.
Okay, thank you.
Yep. All right, 2808 out of 14041. What you got? Point 20? Is that what it rounded to?
Yeah, it's 199.
Oh, 199. Then yes, we will absolutely say that's 20%. I'm good with that. 0.199 and yeah, no, we're good. Okay, so 20% of these kids, right, basically were smoking out of that thing. Now, using just the information I have, could I make a confidence interval? Yes. I actually only need one more thing. How confident do you want to be? Are we going to go with the straight 95%? Because you actually do have to be told, and if you're not told, then you have to choose what kind of a confidence interval you're going to do. How, because it matters. Your z-score will change, right? So if we want to go with a 95%, that's fine. What did we say? Do y'all remember from Friday? I said there was 2 choices. If you use the empirical rule, then you're just using 2, right, for 95%. If you're using your table, do y'all remember what we found on your table? The good news is the people at the AP College Board will take both. 2 standard deviations. If you go look on your table, we found this out on Friday. We'll do some more practice with this today. If I want the middle 95% of my data, then I'm leaving 2.5 off on the top and the bottom. And if you go find 2.5%, it's like 1.96. So you can use that as well. Either one works. So I want to make sure everybody's okay. We're just going to set this up. All right, so you ready? Statistic, plus or minus, critical value, times my standard deviation. Okay, we already have our statistic. It's 20%. If we are going to do a 95%, then we're just going to use 2. All right, we'll just use the easy one, the empirical rule 2. Okay, what is my standard deviation for my statistic? How do I set it up? Come on, guys, it's a proportion. How does it set up? P 1 minus P all over N? Yeah, so what's P? The only one we have.
0.20.
0.20. Technically, it's P hat, right? Because it's from our sample, but do we actually have what the population proportion is? Nope. So we actually just get to use the one that's in the sample. 0.80 all over 14,041. Okay? You're going to have to do one for the plus and one for the minus. So let's see what we got. You can put this all in at one time. We've talked about this before about doing that whole big square root in the calculator, right? And you're really just multiplying it by 2. So if you do one for the plus and then go back and do one for the minus. Anaya, you alive, baby?
Yes, ma'am.
Are you sure?
Yes, ma'am.
You don't sound very confident. Are you tired?
Yeah.
Stop staying up all night partying. I keep telling you it's bad for you. It's going to stunt your growth.
I sure knock out mad early.
You knocked out early?
I have been for the past week. I'm still waking up.
And you're still, like, completely wiped out?
Yes.
Not good. You'll make me start worrying about your health, girl.
Yeah.
Once you make it through the next 3 or 4 weeks, right?
Yeah.
Have they increased your work hours?
Kind of way.
Okay. All right, what you got? One for the upper, one for the lower. Yeah, that's what I got. It's going to be 207 because of the 7 after the 6. 207. And then if you don't have to go back and retype it. Just go back up to it, hit enter, and change the plus to a minus. I tell my kids in algebra all the time, I'm like, don't keep typing in the quadratic formula. It's just dumb. Just go back up and change the plus to a minus. All right, what we get for the low end? Yep. Should be symmetrical. That does look like it's the same distance away, right? From 0.20? So this is a reasonable estimate for basically the population proportion of kids who smoked back in 2007. Somewhere between 19.3 and 20.7% of the population of kids from grades 9 to 12 smoked. I sincerely hope it's less now, but it's probably more. Yeah, as I said, I really kind of hoped it would be less, but it's probably more. So, questions, concerns? Everybody good? Everybody alive? No?
I'm alive.
Is it because it's Monday? No, it's not because it's Monday? All right. Okay, so I'm serious though. Question so far, because if you understand this part, then we're doing good. We can go ahead and talk about how we actually, how we have to phrase this. Remember how we have rules about how we write slope, how we write stuff in context? There's a very specific way we have to write this. Okay? So are y'all comfortable with this? Give it a minute to like compress into the brain. Process it, yes. I never want to overwhelm y'all. I just want to make sure we're processing. Okay, so very specific way that we phrase this. Nope. Nope. That's tomorrow. Oh, guess we have to go to the next one. Oh, never mind. Yep. Okay, we know the conditions already, right? We've done the conditions already. What are my 3 conditions? Come on, what are my 3 conditions, guys? We've been doing it forever. Random. And it's the same conditions we did, yeah. And it's the same exact rules that we did in the last unit, which means if it's a proportion, I gotta have at least, nope, that's for means. At least 10 successes and 10 failures, and at least, or no more than 10% of the population. Yes, too many 10s, I know. 10. Okay, so how they are phrased. It is still state, plan, do, conclude. We are not getting away from that. Just telling you. Okay, when we are doing a state, and Mildani, this is specifically for you, because I know you were talking about reading these and trying to figure out what in God's name I am being asked to do. If you see the word estimate, you are automatically being told to do a confidence interval. And that is what you are going to put in your state. We are estimating at whatever level confidence, whatever they're telling you to do. So if you see the word estimate, you are being told to find a confidence interval, the way it's phrased. Fill in the blank. Whatever percent confidence they tell you to do, if it's a 95 or a 99 or a 96 or whatever, you're going to fill that in. The true population, and it's either going to be proportion or mean or slope, right? That's going to be your, what do we call that? Your estimator. Right, that's your estimator. And then you're going to give me whatever context they told you in the problem. So with our smokers, we would estimate with 95% confidence the true population proportion of smokers in grades 9 through 12. Ta-da! Very, very important word. You don't include it, you're going to get it wrong no matter what. Because that word means that you are referring to the population and not the sample you were given. That tells the people who are grading it, oh, you realize you're actually making an estimate for the population. We're just using the sample. It's the same thing when we start doing the hypothesis testing. You always refer back to the population. All right, that's our state. Our plan? Plan hasn't changed. What's plan? What's our abbreviation? RIN. Yeah. That hasn't changed. That hasn't changed. Plan is always conditions. RIN. Always. Plan. I'm not even going to bother doing that again. All right, do the do. We just did that. That is statistic plus or minus our critical value times our standard deviation. We just did that. So again, not really anything different so far from what we did last unit other than the way it's phrased. Go ahead. Go up. All right. That part? Okay. So I said, write this down. It's a fill in the blank. What were you doing? You better not be filling this into my class. I will talk to Coach McGee and tell him you have to start doing math in his class. My math. Your fitness pal is not Coach McGee? That's not for that class?
He's not making us do it. He's making the kids at home do it right now.
Oh, so you just doing it just to do it?
Not just to do it.
Okay, that's what I say. But after my math is done. After my math. Okay, so do and then conclusion. You ready? Very, very specific. We're going to do a fill in the blank again.
And this is for what again?
This is the conclusion of a confidence interval. State plan to conclude?
Confidence interval.
Yes.
The exact way that has to be.
Fill in the blank, yes. Sometime today. There you go. There are days. Okay. I'm hoping everybody realizes what goes in front of the percent mark, right? Whatever confidence level you're being told to do, 95, 96, 90, whatever it is. This one is your, just like it was before, that's your estimator. This is your context, always given context, and then your interval is exactly what your, whatever you got on your do. Love fill in the blanks, because there's never any doubt about whether or not you're writing it correctly. It's just, okay, I'm done. So if we were talking about the smokers, right, we are, how confident did we do? 95% confident that the true population, what was it? Mean, proportion, or slope? Proportion, that the true population proportion of, what's my context? Smokers from grades 9 to 12 is captured by the interval .193, .207. Not bad, huh? It's really not bad. This is like one of the big things as far as doing a open response problem, is that they'll have you do this and then they'll only ask you one more question. The one more question is usually really good. Something like, let's see, we said the interval was 193 to 207? Okay. So, 3.207. Does that provide enough evidence that less than a quarter of the population from kids aged 9 to 12 or grades 9 to 12 smoke? Yeah, does that provide evidence that less than 25% of the kids in those grades smoke? Yes, because the interval is entirely below 25%. That's actually enough evidence to say less than a quarter of the kids in grades 9 through 12 smoke. That actually counts as evidence, because you're estimating the true mean, and the true mean is obviously somewhere below 25%. So that actually does count as evidence. So again, questions, concerns, comments? We'll do another one just to make sure you've got it from top to bottom.
Miss Austin,
Yep.
is this like recorded and is it gonna be on Google Classroom?
Yep.
Canvas?
Yep.
Alright, cool.
Why, do you have to go as well?
No, I just want to look back at it.
Okay, that's fine. And we're going to finish tomorrow. We're going to start talking about like what confidence levels mean and how to talk about those. Like, what does it mean to be 95% confident? There's an actual fill in the blank for that one too. And it has to do with, that law of large numbers again. If we do this over and over and over again. Y'all remember that? We always have to go back to the law of large numbers, right, Roderick? Okay, so questions or concerns? Like I said, we can do one more just to make sure you've got it, if you feel comfortable with it. Because we're going to finish 8.1 tomorrow. It's mostly just definitions, because after that we actually get into the nuts and bolts of, let's go ahead and do this. One more? I don't mind. Yeah, no, that's absolutely just to make sure you've got it, because you really only need a couple pieces of information to do it. All right, so let's do one more. It is, and but the more practice you get, the better off you are.
Yeah, I just don't.
No, that's fine. The more practice you get, the better off you are. And so it gets into your head and you're just like, really? Okay. Don't have to think about it anymore. Yeah, literally, it's on page 539. The cartoon with Garfield. Taking a look at tomorrow's weather, the high temperature will be between 40 below zero and 200 above. He's never wrong, but it doesn't mean anything. All right, so let's see. Good set of data. All right. Ugh, love political ones. They're so much fun. Okay. Okay. Whew. All right, so believe it or not, we actually have everything that we need. I could have just as easily told you that instead of telling you 51%, I could have just as easily told you that 1,020 voters stated they were in favor of free college. It would have been the same thing. You would have just had to go back and get the percent, right? All right, so state plan to conclude. Let's go. Come on. How do you phrase it? Go back to the last page if you need to, wherever you took a screenshot of. The last page you took a screenshot of. As far as if you want to know how to state it, pull that up, because that's exactly how you state it. Oh, okay. Yeah, they're Miss Mitchell's. She left like all of her stuff in here. She'll be back after 4th, I'm sure. They are. They're very good. Okay. Yeah, 95% estimate. Mm-hmm. Yeah, say it again. Okay, go ahead. The true, you had it right. True population, what? Good. The context. There you go. Yeah, as long as you get the context in there. Okay, doing good. Rin. Yep. Rin. And it does not want to move. There we go. Okay, Rin. Random, my fault. I did not put it down. Most of the time it's going to tell you it's an SRS, random sample. What is it going to tell you if it's an experiment? I heard you. I just want to make sure you said it right. Yes, random assignment to treatments. Very good. So in this case, we're just going to say random given. Okay, independent. How many voters did we take? 2,000. And that has to be what? Uh-huh. You got it. Where'd you go? There you go. Less than 10% of all voters. It just has to be because they didn't even tell us where. They just said voters. And you know they do vote in other countries, so we have to include them as well. All right, normal. How do I know whether or not my data is normal? This is a proportion. What do I have to guarantee? This is the 10. 10, 10, 10. I've already got the 10%. Now I need the other 10s, which are... Since you're being given the proportion and not the count, you're going to have to do it yourself. So it's literally 51... I hate technology today. 51% of 20, or of 2,000. Stop being weird. 51% of, wow. It's just being ridiculous today. There we go. Times 2,000 is greater than 10. And 49% times 2,000 is greater than 10. Anybody wondering why I would do it that way? 51% would be my success rate, right? At the beginning it said 51%, so the other part has to be 49. Yeah, it has to be greater than 10 people. I'm just trying to prove that 51% of 2,000 is greater than 10 people. I really hope to God it is. Stop moving. God. Ugh, all over the place. Slide. There we go. I'm even just doing this just so I can get the 49 to actually have more room. Okay, there we go. And 49% of 2,000 also has to be bigger than 10 count. I'm seriously hoping that they both are, yes? If they are not, then we have some other issues that we have to deal with. But those are both bigger than 10. Do I actually need to multiply out 49%, 51% times 2,000? Nope. All I'm proving is, yes, I know it's bigger than 10. I'm good. Okay, so do the do. 51% is already there. I don't actually have to do the count anymore. It's just 0.51, right? Do it as a decimal. Okay, plus or minus. What's my critical? You said it. Go ahead. 2. Yeah, 2 standard deviations. And then my big standard deviation is... It's the proportion one. It's the one with the P, 1 minus P. Yeah, you have to use the one you got, right? 51 and 49? Yeah. You got it. Mm-hmm. And then 0.49 because that's the other... Yep, over 2,000. Nice job. You got it.
Okay.
Y'all are doing great. You got it. Increase your confidence. Ha ha ha. Yeah, I have the shirt that they made that one year that literally said, I survived AP Stats, so you can be 99% confident that I'm always right. And they put the confidence in a formula on the front of it. So I walk around with that, and people just sort of look at you like, what formula is that? Yes, that's the whole point, is I know what it means, you don't, it's okay. All right, so remember that you do 1 for the plus and 1 for the minus. Anaya, you still alive? Anaya has left us. She is gone. She is gone. She has left the building. All right, you got your calculator. Let's go. Come on. You don't grab your calculator and start doing this. I am not even going to show you how to do it in the calculator. And I will show you the shortcut, but your butt better get moving. What, not show you? Because you ain't doing the work by hand to start with. The rule is always we do it by hand first. No. Always by hand first. Because forbid you forget how to do it in the calculator. You got to be able to fall back and do it by hand. All right.
Nothing.
What'd you get? Boo Boo, did you put in 51 plus 2 times the parentheses 0.51, 0.49 over 2,000?
Maybe.
I don't think you did.
You know what? You shush.
He's so cute when he pouts. He really is. What? I'm gonna aim higher next time. Right here, right for the forehead. All right, 0.5 what?
3-2.
Very good. There's the upper level. Now, just go back up instead of retyping the whole stupid thing and go back up and change it to a minus. Yeah, don't do that because typing it in all over again is just irritating after a while. Questions, concerns, other than my prints or my commas in the wrong place. Yeah, love technology. All right, so all we got is the conclude. Yes. And all it is a fill in the blank, guys. Come on, we can do this.
Have you ever been shocked when plugging in a plug in the outlet?
Yes.
I've done that.
I'm hoping that is still plugged in, being that you're supposed to be still charging your iPad.
I've done that a multitude of times.
Stop playing.
I did it with like a big one. It was a lot of electricity. One of those big ones, and you had like 3 phones. I was plugging in, like I had like this computer back on elementary school, and like when it was damaged, I had to plug it in to run the whole thing. So I could plug it in, but yeah, I guess I was still holding on to the silver part, and I pushed it in. And electricity.
You were holding on to the ground wire.
Oh yeah, and electricity.
Fail.
And I had to
Fail.
Oh, and there was another field, so we got electric fence on it. We got to put it down for like the skateboarders.
All right. Give me my fill in the blank, and then you can tell me about it. Yeah, if you have to, go back to the screenshot you took of how we write this. I'm waiting. It's coming. Because at this point, I've given up on technology too. You know what? Done. I'll type the stupid thing. Probably go faster. Maybe. Okay.
Oh, you.
All right. We are 95%. Present that the. All right. That the what?
True population.
Okay.
We used to. I'm gonna throw this in.
Go ahead.
In favor of free college education?
I'm done. I'm done. I'm done.
Shin proportion. Roderick. I don't care.
Of voters?
I'm gonna throw some at you next. Shh. I'm trying to make him do this.
Okay, sorry, go ahead.
Oh, vote. Wait, we're gonna vote right here. Voters is captured by the interval who were in favor of free
You have to do the context, otherwise you don't get full credit.
and free education. Captured by the interval.
College education.
Is-
No.
No, you have to give the context. By the interval.
Point 487 and point
532. There you go. All right. Not too bad as far as like if you're talking about an open response question. That one really would not take you like 12 minutes, 15 minutes at all. Even if they threw an extra question in there, like, do we have proof that it is greater than 50%? Yeah, because our interval does go above 50%. Is there a possibility that it could be less? Yeah, because the interval again goes below 50 cent. 50 cent, 50%. 50 cent, 50 cent. All right, so we are going to be done with 8.1 tomorrow, and we're going to be starting on 8.2. Honestly, after we get through like the bones of it about what the pieces mean, all we're going to be doing is this and doing a difference in proportion one. That's it. So be prepared. We'll be doing a couple of open responses tomorrow. Short ones. They don't take very long once you see how they go. Okay, so questions, concerns, comments? Everybody good? Possibly? Okay, just making sure. I'm going to go ahead and hit stop on the